Hi everyone. Hope you're having a lovely morning. The sun is out here. So today we're going to be thinking about solving equations. We're going to go through some different types of linear equations, and hopefully we'll get a chance to do some quadratic equations as well. So quadratic means that the highest power is a power of 2. So an x or variable squared is the variable to the highest power in the equation. Okay, and there are a few ways that we can see this in algebra. So first of all, we had a little bit of expanding and simplifying to finish off from last time with some multiple sets of brackets. Okay, so we'll go through these together, and it'd be great to know how you get on. You can always send me a message on social media. If you're on Facebook, you can write a comment. If you're on YouTube, write a comment on any of the posts I've made if you've got any questions, and I'll get back to you later on. It'd be great to hear how you're doing. Okay, so expanding and simplifying. So here we've got a single bracket to expand. And remember, I'm multiplying everything in the bracket by whatever's on the outside. We have then something else taken away from it, but that's okay. We'll sort that out later on. That will just need to be simplified at the end. So we're going to do 3x times 2x. Remember, we always do the number times the number. So 3 times 2, that will be 6. And then we've got x times x. That's going to be x squared. And then we've got 3x times positive 3. 3 times 3, that's 9, positive 9. And then the x doesn't have any other letters to be times by, but we just write it right next to the 9 to show that it's 9 times x. And then we've still got this minus 5x to write on the end. And then when it comes to simplifying, x squared terms stay separate to x terms. So the 6x squared stays on its own. And then we've got a positive 9x take away 5x. So we need to think about what 9 take away 5 is. 9 take away 5, that's 4, positive 4. So that's how many x's we have. Okay, so these are not like terms, even though they both have x's in them. For them to be like terms, they need to have exactly the same combination of letters. And this has an x times x, whereas this one has just an x. So hopefully that makes sense. Also, hopefully you can see that this is 2 sets of single brackets. If it was double brackets, there'd be nothing in between the brackets. They'd look like this. And remember, we have a particular way, the FOIL method, of multiplying out double brackets, like these. But these aren't double brackets because they've got signs in between them. It's a bracket times by something plus another bracket times by something. So it's 2 sets of single brackets. So let's multiply these out. Let's start with the first one. So we've got 2 times x, that's going to be 2x. 2 times minus 4. So every time we do this, we need to think carefully about the signs. So 2 times minus 4, that's minus 8. And then we're going to move on to the next one. And I'm going to think really carefully about this sign here. And later on, we'll see as well, people sometimes get confused by this and end up getting a sign wrong. So we've got 3 times 5, that's positive 15, because they're both positive. Positive 3 times 2x, positive 2x. So I'm going to do 3 times 2, that's 6, and then stick the x on the end to show that it's 6 times x. And then we have some x terms to collect together. I'm thinking really carefully about the signs here. 2x add 6x, that gives us 8x. And then we've got some number terms to collect together. I might use a different colour for this. We've got a minus 8 plus 15. Negative 8 add 15, which is the same as positive 15 take away 8. So that's going to give us 7, positive 7. So 8x plus 7. Okay, so these ideas are really important because they can sometimes come up. So I think you'll be able to do this one yourselves, but do think really carefully about that minus 2a And make sure you're timesing everything by minus 2a. So this last term is going to be minus 4a. Okay, sometimes people forget that, which can cause problems. And the same with this last one. So we've got 2 times 7b, that's 14b. Then we've got 2 times negative 6. So a positive times a negative, that gives us a negative answer. Now, just like I was saying here, we must be careful about this minus 3. We're going to do minus 3 times 5, which is going to give us minus 15. And then we have minus 3 times minus b, a negative times a negative, which gives us a positive, positive 3b. So one of the biggest things, really, that tends to go wrong in these sorts of questions is here, people not timesing the a and the positive 2 by something negative, only using the minus sign once and not using it again for the next term. So do watch out for that. A little bit of a tip. So I'm going to then simplify. We've got 2b terms, 14b and 3b. So that's going to give us 17b. And then, let me quickly change the colour again. We've got minus 12, take away 15. Negative 12, take away 15. Negative take away something, we're going to get more and more negative. That's going to give us negative 27. Okay, so hopefully that makes sense. And have a go at that last one, the middle one yourself. And I've put some extra practice questions on the end as well with some answers, the end of the PDF. Okay, so let's get on to solving then. That was really just a finish, a little final bit of expansion there. So I know that you lot will have been solving equations for a while. You can always pop me a comment if you're not sure, if I'm going too fast, and I will link you a previous class where I explained this a bit more slowly. But I'm going to go fairly quickly for the solving today, okay, in comparison to previously. So we're going to use something called the balance method, where we always do the same thing to both sides. And we're trying to get the x on its own. So solving is finding the value of the letter, and we try and get the letter on its own, because then whatever's on the other side of the equal sign is the value of it. So here we've got a plus 3. I'm going to take 3 away to cancel that out. So we have just 4x on this side, because plus 3 take away 3 is 0. So I'm going to take 3 off the other side as well. Whatever we do to one side, we always do to the other side. So I'm going to end up with 4x on the left, 11 take away 3, so that's 8 on the right. So now we still haven't quite got x on its own. We've got this, x is times by 4 at the moment. So we always do the inverse to undo what's been done to the x. So 4x divided by 4 gives us x, and then 8 divided by 4 gives us 2. So there's our final answer, okay? And as we go through these questions, they're going to get a little bit harder, but it'll be really good to know if you all have any questions or want me to explain anything. So we've got this minus 3. So this time I'm going to add 3 to cancel out the minus 3. We're always doing the inverse, the opposite. So we're going to end up with 7c on the left here, and 18 add 3. So that's going to give us 21 here on the right. Now we've got c times 7, so I'm going to divide both sides by 7 to get the c on its own. So we're going to have c equals 21 divided by 7, which is 3. Okay, brilliant. I'm keeping my eye out for any questions. Remember, if you're on YouTube, you can always pop a question on any of my posts about the classes, and I'll get back to you as soon as I can. Right, I'm going to take 3 off here to undo this plus 3. So I'm going to do the same to the other side. We always do the same thing to both sides of the equation. So this all balances out, cancels out, and then we've got 10 take away 3, which is 7. Watch out for this. Lots of people do this the wrong way round, but this is a divided by 3, isn't it? So the opposite of dividing by 3 is timesing by 3. We're going to make sure we times both sides by 3. So a divided by 3 times 3 is just a. That's how we get the a on its own. But we have to do the same to the other side. So that tells us a is going to be 21. And let's do one more. We've got a minus 3 here. Gosh, there's lots of 3's in these questions, isn't there? Oops. So I'm going to add 3 to both sides. That gives us C over 6 equals negative 8 plus 3. So have a quick think about what that is. Remember, when we're adding and subtracting, we're not using the two negatives make a positive, none of that. When you're adding and subtracting, you can think about a number line. We're on -8, we're getting more positive by 3. We're getting closer to 0. So it's a smaller negative, if you like, less negative. So we're going up to -7, -6, -5. Okay, so c divided by 7 is -5. So now I'm going to divided by 6, sorry. Now I'm going to times both sides by 6. So I get c equals -30. There's my answer. Brilliant. Okay, what about when you have an unknown on each side of your equation? There's a little step. So I'm going to keep introducing you to little steps that we're going to do at the beginning. And then you should see it starts turning into what we've been doing previously. So the idea with solving with an unknown on each side is to make sure you get all the letters on one side and all the numbers on the other side of the equals sign. Then we can basically do what we were just doing. I've got a tip though. I recommend that you always try and undo or cancel out the smallest or most negative number of the letter variable. For example, we've got 3x here and we've got an x here. So I'm going to take x off each side. I could take 3x off each side if I wanted to. The reason I'm suggesting we don't do that is just because it gives us a negative x term then, which is actually not a problem, but it's going to mean then we have to do a little bit more playing around with this to sort it out so that we don't have that negative x, because we need to know what positive x is. So my recommendation is cancel out the smallest number of x's or c's or a's. So 3x take away x, that's going to give us 2x plus 8 equals x take away x is just 0, nothing. 1x take away 1x is 0x. So that's going to leave us with 12. Okay. So now we're back to the kinds of questions we were doing before. So I'll do this quickly. We're taking 8 off each side. So we're going to have 2x equals 12 take away 8, which is 4. And then we're dividing both sides by 2. So we're going to end up with x equals 2 as our final answer. Okay. So let's try and carry on thinking about those principles. Maybe you can work a little step ahead of me if you're following me okay. So we've got a 2x here and a 5x here. So my strategy is going to be to cancel out the smallest number of c's, this time it is actually. I'm going to take 2c off each side, okay? If you like, you can take 5c off each side, but you're going to end up with a negative c term at the end. So you'll have to divide by a negative as your last step. If anyone has any questions about this, I can demonstrate it, perhaps next time, but do let me know. So 2c take away 2c, that's just going to be 0c, so that disappears really. We're going to end up with 4 equals 5c take away 2c, that's 3c, minus 5. If it's not necessary, but if you like, you can flip both sides of the equal sign over. And then you'll see it will look very, very similar to what we were just doing. So if I pick up the 3x minus 5 and put it on this side, and I pick up the 4 and put it on the other side, I'm just swapping them over. That's absolutely fine to do, no problem at all. Then we're going to be adding 5 to each side, so 3c equals 9, and then dividing both sides by 3. So c equals 3. All right. Oh, what about this one? Gosh, this looks like it's in a funny order. Because we've got our number and then we've got our letter term, which we're not used to seeing. But I'm just going to carry on exactly like usual. Sometimes you'll see things that look a little bit different, but it's okay. As you practice, you'll find that you can deal with them more and more. So I'm looking at my two A terms and I'm looking for the smallest number of A's. Well, that's actually negative 3A because negative 3 is a smaller number than 1. This one's 1A. So smaller or more negative. Think of it as more negative if that helps. So I'm going to add 3A to both sides. And this will stop me having any negative letter terms, negative variables. So I'm going to end up just with a 2 on this side. A add 3a, that's 4a on this side, plus 10. Like I said, we can swap the sides over like I did here. I'm going to carry on without doing that so that you can see that that's absolutely fine as well. So what I'm going to do is I'm going to take 10 off each side. So that'll give me just 4a on this side, because 10 take away 10 leaves us with 0. There's no number term here anymore. Then we've got 2 take away 10 on this side. That's minus 8, negative 8. Now I'm going to divide both sides by 4. So that gives us negative 2 is a. In other words, a is negative 2. Okay, and let's do one more together. Oh, we're really getting through these. Okay, ooh, this is interesting. We've got an x on each side. So yeah, we need to do the unknown on both sides step. Let's look for the smallest number of x's. That's going to be this one, because this is just 1x. And we're going to take 1x off each side. We're going to end up with 3x minus 12. Don't let this confuse you, because x take away x is 0, and we must write that in. Otherwise, we've not got an equation anymore. So sometimes people get to this point, 3x minus 12, and then get a bit confused because they're not sure where the equation's gone. It's turned into an expression, but it hasn't really, because we've still got this equals, and we know that this is now 0. So we need to write that number in. Now, solving like usual, adding 12 to each side. So 3x is 12, dividing both sides by 3. So x is 4. Excellent. I can't see any questions at the moment. Hopefully that means this is all making sense to you all. Fantastic. Right. If you end up with brackets in your equations, normally it's a good idea to multiply out any brackets before you start. The exceptions would really be if you're using a bracket as some kind of more advanced technique to help you solve. And we might talk about that later or next time. So for these questions, I'm seeing, oh, okay, there's a bracket there, and I need to solve. I need to find what x is. And I'm going to say, okay, let's multiply out the brackets first, and then we can see what we've got. So remember, we're multiplying everything inside this bracket by whatever's outside on the front stuck to the bracket. So we've got 5 times x, that's 5x. We've got 5 times negative 1, that's negative 5. And this side hasn't changed at all, so I'm just going to write it out exactly as it is. Okay. What do we have now? What stage are we at with this question now? Well, now I'm noticing that there's an x on each side. So the next thing we need to do is sort that out. So now I'm going to look for the smallest number of x's. That's the 1x on this side. So I'm going to take x off each side. That means on this side, I'm going to have 4x minus 5. And on this side, x take away x is 0. So I'm just going to be left with the 3. Now, hopefully, it's looking more familiar. So we're going to do the opposite of taking away 5 to both sides. We're going to add 5 to each side. That gives us 4x equals 3 add 5, which is 8. And then I'm going to divide both sides by 4. So we've got x equals 2. What about this one? Ooh, okay, similar kind of thing. We've just got more brackets to expand. Brilliant, let's do it. We'll do a couple of these together. So this one, we've got 2 sets of brackets to expand. Okay, let's do it. So we've got 6 times a, that's 6a. 6 times negative 3. Remember, always think about the signs. So that's going to give us negative 18. Then we're moving on to the second bracket. So we've got negative 3 times 4, that's positive 12. Positive 3 times 4, did I say negative 3? Ah, I'm talking too much today. So negative 3 times a, positive 3 times a. Oh my gosh. Ooh, just give me a second. Right, let's start that bit again. Positive 3 times positive a gives us positive 3a. Hopefully because you're watching at the same time, You can see me pointing, you can see what I'm referring to. Okay, what about some A terms to simplify? This is a 6a. Remember, this minus sign is stuck to the front of the 18, so don't let that confuse you. Then we've got a positive 3a here. So let's combine those together first. So 6a add 3a, that gives us 9a. And then we've got a negative 18 plus 12. So negative 18 add 12, that gives us negative 6. And then we've got 12 on this side. So finally, we're adding 6 to each side. So we get 9a equals 18. And then we're dividing both sides by 9. So we end up with a equals 2. There we go. Let's do one more. I think this one will be worth going through again. And then we'll move on to something else. So we've got some brackets. Let's do those first. So we've got 6 times b, that's 6b. 6 times negative 5. Always think about your signs. So that's going to give us negative 30. And we're still just going to have b on this side. Great. Now, what do we do next? So next, I'm noticing there's a b on each side. I'm going to cancel out one of the sides. Doesn't really matter, but ideally, let's look for the smallest number of b's. That will keep our b term positive, and it will usually mean fewer steps in our question. So we've got 1b over here, but we've got 6 b's there. So I'm going to take 1b off each side. Don't forget, b take away b, 1b take away 1b is 0. And we must put that in, otherwise the equation, well, it's going to look like it's not an equation anymore, and it's going to be a bit confusing. 6b take away b is going to be 5b, and then the minus 30 stays as it is. Excellent. So 0 is 5b minus 30, or we could flip it round to say 5b minus 30 equals 0, if you want to. Now we're going to add 30 to each side. So 5b equals 30, and divide both sides by 5. So b is 6. So I bet you could have a go at that last one now. And it'd be great to know how you find it. Fantastic. Oh, okay. We might have time for a couple of pages here. Oh, this is exciting. So first of all, these next 2 pages are to do with solving when you have a squared variable. And the way we need to solve, or the options we have, depends on what else we have in our equation apart from the squared variable. So in these questions, we have our squared variable and we have some number terms. These ones are a little bit easier, and we can solve them using similar techniques to the previous questions. The only difference is right at the very end, we're going to get the x squared term on its own, and then we're going to square root it. So let's do it. So we're going to try and get the x squared term on its own. We're going to do that by taking 5 off each side first. That means x squared equals 21 take away 5. What's 21 take away 5? So that's going to be, oops, 16, right? And then we're going to square root. So we're going to think, what would you times by itself to get 16? Now, for some of you, you might be able to use a calculator if you're doing IGCSE, if that helps you. Hopefully, if you know your square numbers, the square root of 16 is 4. However, your calculator always gives you the positive answer, the answer of 4. But there's also a negative answer. Because if I think about what I could square to make 16, I could square 4 to make 16. 4 times 4 is 16. But I could also square negative 4 to make 16. Minus 4 times minus 4, that would be a negative times a negative, which gives us a positive answer. So there'll always be 2 answers with a squared variable. In these sorts of questions, one will be positive and the other will be negative. But we'll be seeing some different questions either shortly or maybe next time where you might have 2 completely different answers. Okay? So let's do a few more of these. So 2a squared equals 8. Remember, we're getting the x squared on its own first. I'm going to do that by dividing both sides by 2. So we're going to get a squared equals 4. And then we can square root. So a is going to be 2 because 2 squared makes 4. But remember, a could also be negative 2 because negative 2 squared also makes 4. Right? Any questions about that? Fantastic. So what about question 3? So we're going to try and get the y squared term on its own. We've got y squared divided by 4, so we need to times by 4. So we're going to times both sides by 4. That gives us y squared equals 16. And then we're going to square root both sides. So y is 4, and y could also be negative 4. Brilliant. One more. So they can get a little bit more complicated. So here we've got 4y squared minus 1 equals 8. So, but we're still going to use the same order as we did in the previous questions, which is really a kind of reverse BIDMAS or BODMAS if you think about it. I always think about it as it's like we're undoing the equation. So we have to do the opposite of what we would do with BIDMAS because it's like we're doing it in reverse. So that's why we undo the adding and taking away first. So the minus 1, we need to add 1 to balance that out. So we add 1 to this side as well. So 4y squared equals 9. Then we need to do any dividing or multiplying, as long as there are no brackets involved. So we've got a times 4 here. So we're going to divide both sides by 4. Oh gosh. So we're going to end up, oh, this is quite a tricky question. We're going to end up with y squared equals 9 over 4, 9 quarters. And then finally, we're going to square root. So y equals the square root of 9 over 4. And that would be the square root of 9, which is 3, over the square root of 4, which is 2. So 3 over 2 or negative 3 over 2. Gosh, that was a particularly tricky one there at the end. Hopefully that all made sense. Just to get us started, and we'll do some work on this next time, solving 3-term quadratics. So something that's different about these questions is that we have a x squared term, we have an x term, and we have a number term. So we have this x term here that we didn't have previously. So we can't just use the methods that we were using previously. It's not going to work. However, when this equation has a 0 on one side of it, then there's a cool method that we can use to solve it. And again, it will give us 2 different answers. What we're going to do with these questions next time is we're going to factorize this into double brackets like we did last week. So we're going to turn this into 2 things that times together to make this. And we'll talk more about that next time. And then when we do that, we know that this times this equals 0. And what do you know about things that times together to make 0? Have a little think for a minute. Whenever you end up with 0 as the answer to a times table question, what does the question have what do all these questions have in common if they have an answer of 0? Can you think of any questions that have an answer of 0? Well, 0 times 0 makes 0. That's 1. 3 times 0 makes 0. A million times 0 makes 0. Actually, anything times 0 makes 0. So what we know, once we factorize this, is that one of these brackets equals 0. It must do. because keep thinking about it if you like, but I don't think you'll come across anything. I don't think you'll be able to think of any numbers that you times together to make 0 where one or both of those numbers aren't 0. So that's something to have a think about. And that's how this method that we're going to think about next time works. Okay, so for next time, if you haven't watched last week's class, make sure you've watched it and that you've had a little think about factorizing, because we're going to be using that. Factorizing quadratics like this, 3-term quadratics. We're going to be thinking more about that next time. So well done, everybody. That was awesome. So we've got some extra practice questions. You can download those from the Coffee site, and the answers as well, which are on the next slide. And I'll look forward to seeing you next time. Have a lovely rest of your day. Bye, everyone.